Hello, everybody. This is Stephen Feuerstein. Welcome to our latest edition of AskTOM Office Hours with a focus on PL SQL. Thanks for joining us. With me, I have, as usual, Chris Saxon, a member of my team. His official title is Oracle Developer Advocate for SQL, but he knows PL SQL and Oracle Database really well. Chris, why don't you say hi?
Hi, everyone. Good to meet you all.
I'll even show his face. There we go.
Yeah.
So Chris and I and a number of other members of my team work on Oracle Database, and our focus is on making you more successful with our technologies. And that's what we're going to do with our AskTOM Office Hours today. So let's see, I'm just going to fiddle around with my video screen. There we go. So the focus for today is collections, and what I'm going to do is kind of spin through some of my favorite features of collections, not get into a detailed training on those things. And then we'll take a look at some questions that you've given us and basically explore any questions you've got. So thanks for joining. Let's go. So briefly, collections are the way you construct arrays and lists and stacks and queues and all that kind of stuff in the PL SQL language. There are three types of collections. There are associative arrays, nested tables, and varrays. Sorry, three types of collections. They each have their different characteristics. It can be a little bit tricky to go through all the details. The point of this office hour session and my brief introduction is not to get into the details, but to be aware of those things. And I'll show you how you can get lots more information about all of this stuff. In fact, I'm sorry, let's go back to the homepage for a second. Just this morning, I put up on my blog, Stephen Feuerstein on plsql.blogspot.com, a PL SQL collection resource center, a blog post that gives you links to key resources on working with collections. I've given you a nice short bit.ly, PL SQL-calls, so you can visit there after this session and at any time and get pointers to getting going with collections. The bottom line is that collections are absolutely key data structures for performance-related features in PL SQL, and way beyond that, including things like table functions. So here are a few of my favorite collection things. We'll start by taking a look at banishing row-by-row SQL processing, one of the bogeymen of performance in Oracle Database and really any relational database. String index collections, you can index by integer, that's the default, but you can also with associative arrays index by strings, and that's really cool stuff. Nested collections are among the most complicated structures I've ever worked with in PL SQL, but they are very powerful. Essentially, they allow you to normalize your variable data structures in PL SQL, just like you'd normalize your structures in the database. And table functions, oh my gosh, selecting from a function, the collection returned from a function, as if it were a table, a set of rows and columns. The possibilities are numerous. So I'm going to share some of this stuff with you. Now, as I'm doing this, I would love it if you could share or get ready to share your ideas as well. You can type them in the chat. Chris will keep an eye on them. We can even unmute you, and you can tell us your stories of collections. So we'd love to hear from you too. This is a community effort in every way possible. All right. First, I thought I would start with a little quiz. So the quiz is, what's wrong with this code? What problems could result? So what I'm doing here, for those of you who are relatively new to collections, can I turn on my pen? No, I can't turn on my pen. I'm declaring a new type of array. So a new type in the database, employees T. It's a table of, whenever you see that is table of, then what it's telling you is that it's a nested table or an associative array. If it's a varray, then it'd be a varray. And each element in that collection has the same structure of my row in the employees table. Then I declare a variable based on that type. Then I say select star bulk collect into employees. Bulk collect is the feature that leverages collections and integrates it into the SQL interface with SQL, so that instead of getting a single row at a time, I can get multiple rows with a single fetch. In this case, get me all the rows in the employees table with a single fetch. And then I iterate through the collection. Notice referencing one of the methods, which is a function that I attach to the name of the variable. By the way, this was the first introduction of object-oriented syntax into PL SQL back in Oracle 7.3, believe it or not. And then I display the last name of that employee. So what's wrong with this code? What sort of problems could come about with this code? So go to the chat window. You should see a little chat icon in the bottom of your Zoom window. Click on that and you can type in a chat message. And I have a response from Niels, not surprisingly. Excessive memory consumption depending on the size of employees. That is exactly right. So let's explore that for just a moment. So what this piece of code does in a very elegant, concise way is say, give me all the data in the employees table and dump it into this array. Nice. But the thing to remember always when working with collections is that collections, just like any other variable, any other constant that you declare and work with in PL/SQL, consume PGA memory, process global area memory, that is per session memory, and you can definitely run out of per session memory. So the thing to remember when using collections is that they consume PGA memory just like an individual string variable, but with a collection, you can have 10 or 1,000 or 10,000 or 1,000,000 elements in that collection, each one of those consuming PGA memory. So with individual variables, you don't really care about PGA memory very much. With collections, even with large records or object types, you need to pay attention. So a couple of tips there is that when you're using bulk collect, always use the fetch limit approach to control the amount of PGA consumed. Essentially, fetch 100 rows at a time or 1,000 rows at a time. Maybe we'll have time to look at an example in a little bit. We'll do a future office hours session on for-all and bulk collect as well. In addition, if you're using table functions, consider going pipeline, creating a pipeline table function, and that will drastically reduce the amount of PGA consumed. Now, before moving on, Himanshu also said more context switching. So let's go back to that for a second. Context switching is about to come up, but whoops, especially if I go in, there we go. So the idea of context switching that he mentioned, or she, is moving back and forth between the SQL and PL/SQL engines. Now, in this case, context switching is not a problem because I'm doing a single select bulk collect. So it's only one context switch. That's actually the power of bulk select. The problem is that I've traded off a reduction in context switches and with the effect of using too much or potentially too much memory. And by the way, one of the other ways to think about code like this is it's a time bomb piece of code. You could write it today, the employees table has 100 rows in it, and it works great, it works fine, no problems. And over the years, you leave and move on to other projects or other companies. Nobody has looked at the code in 5 or 10 years, but the employees table has been growing and growing and growing, and suddenly, boom, you get errors. Now, I don't know about you, but I hate to get errors from code that hasn't changed, that hasn't been changed for 10 years, and was owned by and written by and known by a person who's no longer there. Bad stuff. So when you can recognize these kind of issues in advance, you can compensate and make sure you can protect your code from these issues in the future. Okay. So what we want to do in general when it comes to, so I want to talk about my favorite things about collections, and by far the most important favorite thing is its usage in bulk processing. The biggest problem we see with our customer base, and these are even with relatively experienced accounts, is the issue of row by row, or as Tom Kite used to put it, slow by slow SQL processing. So we have this real world performance team. They're like the SWAT team of performance for Oracle database. They go all around the world working with our biggest customers, helping them with these kinds of issues. And amazingly enough, they see these problems even in these large accounts. And the basic pattern that you want to look for and avoid is in which you're fetching rows in a loop or any kind of loop processing. And within that loop, you're executing individual DML statements. Update this row for this bind variable 1. Update this row for bind variable 2, for bind variable 3, et cetera, et cetera. Now, it so happens that the cursor for loop is automatically optimized to fetch 100 rows at a time. So that's pretty cool. And you often can leave those alone. It looks like a single row fetch, but the fetch is not. But the problem could be in the non-query DML. So here's the problem in a picture. Basically, when your SQL and PL/SQL are very tightly integrated, but there are limits to that integration. There's certainly separate execution engines in the database. When I run a piece of PL/SQL code and the PL/SQL engine encounters a SQL statement, it prepares the statement, it prepares the bind variable values, and it passes it over to the SQL engine. The SQL engine does its thing, passes information back. And that's the context switch that Himanshu was talking about. So switching between the PL/SQL and SQL engines, there's a bit of overhead each time you do that. So that's one of the biggest ongoing problems with the way we write our applications are the number of context switches. And it's implicit often in the way that people end up writing their SQL within PL/SQL. So here we have an individual update statement that's being executed for each row returned from that employee cursor. So what do you do about it? You switch to bulk processing. And for that, as you're about to see, you need collections. So the basic idea is instead of having a for loop, I have a for all statement. And it binds an entire array into the SQL statement, not the individual elements of the array. So it generates essentially 1,000 update statements, really, let's say one update statement with 1,000 bind variable values, passes that all over to the SQL engine with one context switch. The SQL engine does all the same stuff it used to do, and then passes back the results in another single context switch. So this move from row by row processing to bulk processing is a key performance enabler. Now, since I didn't mention this before, let me emphasize. The best thing you can do is find a way to rewrite your PL/SQL code so you don't need PL/SQL. In other words, instead of having an outer loop and then within the loop you do an update or an insert or delete, chances are you can find a way to do that in pure SQL, even if you put that pure SQL inside a PL/SQL block. That's the best solution. When you can't do that for a number of possible different reasons, then you can fall back on for all and bulk collect. To use bulk collect and for all, you've got to use collections. The bulk collect query fills the collection. The for all binds the collection to the placeholders and passes them across in bulk. Now, what I'm going to do is switch over to Live SQL and take a look at some examples, or at least one example, because I'm already 12 minutes in. Hopefully, you're all familiar with Live SQL. Live SQL is a website that provides 24/7 access to Oracle database in the latest version, which means, for example, database 18c. Right now, you can be learning about Oracle database 18c features, even as it's unfolding for widespread usage right now, both in the cloud, on-prem, and soon our 18c XE release coming up in October or November. And what you can do is visit the site and write your own stuff, or you can search. So for example, I'm going to search for all. I think I'm going to search. There we go. And you'll find lots of different scripts, mostly my stuff, on for all, bulk collect, bulk processing. Now let's just click into converting from row by row to bulk. If I was doing a whole session on this, I would spend a lot more time on it. And as I said, we'll probably do that in a future office hour session. But right now, what I just want to show you is the conversion process. Here's the before version. It's short and sweet. For every row in my cursor, I do an insert into my history table. I do some complex computations, and then I update the employee with the new salary. It's nice, it's short, it's lovely to look at and lovely to work with, but the performance of it is absolutely horrible. So I've decided to go to bulk processing. And one of the things I wanted to show you is not only the basic ideas behind it, but that your code gets a little bit more complicated and longer if you want to do it right. So here's my new block of code. Get my cursor, go through my loop, and here's my fetch bulk collect limit. So I wanted to show you that. Instead of doing a single select bulk collect, you fetch bulk collect, specify how many rows you want to fetch at a time. You can even make it a parameter. So you can adjust it depending on workloads or how much memory you have available. And then I break things up into phases. First, I do all my inserts, I do my adjusted compensation calculations, and then my updates. And each one of these inserts and updates are now their own separate for all statement. So here's my insert inside my for all statement. So I batch them all in at once. If something goes wrong, then I can iterate through the source of the errors and compensate for those. And again, we don't have time to go into the details. I will cover this in more detail in a future session. And update employees for all. And here we have even another trick with for all, which is indices of, when you have sparse arrays that are driving your collection processing and your binding. So for today, I think that's probably enough. Check out Live SQL for bulk processing examples, and you'll see how collections are very much put to use there. Cruising along, string index collections. So by default, I think most of us think about a collection or an array as being indexed by integer. What's in the first position, the second position, third and fourth, and so on. You certainly can and do use collections that way. But string index collections, indexed by varchar2, can be really pretty cool. So rather than look at the code right here, though I'll make sure that I'm not hiding it with my big fat face, let's go back to Live SQL. Look at an example. Actually, sorry, time for SQL Developer. So a long time ago, I needed to build a package that kept track of what strings I've been using. I was doing a complex code generation project, and I was generating the names of variables, and I wanted to make sure that I didn't end up with two variables with the same name. That can cause problems. So I wanted to keep track of what was used. Here was my first sort of intuitive way of building that. I put together a little API in a package. Mark a string as being used, is a string in use. I created a collection of used strings. So a table of variable names, I'm using a subtype there, indexed by integer. Whenever I want to mark a string as being used, I add it to the list sequentially. So first count is 0, so the first one goes into 1, then 2, then 3, then 4. And then if I want to find out if a string is in use, I iterate through the array until I find a match. Now you can say, looks pretty good, pretty short, pretty clean. What's the problem, Stephen? Two problems. One is that this is the sort of algorithm that is not data neutral. As your collection grows, as the number of variables you're using grow, it could take longer and longer to do essentially a full collection scan. The second is that, well, it's a lot of code that I might not need. So here's the anti-pattern to look for. If you're writing code or reading code in which you see people doing scanning through the collection looking for a match, think of it as the same as a full table scan in SQL. It might be okay, but it could be a problem. Do you need to do that? In this case, you don't. So in my second iteration of my string tracker package, I changed my collection to be indexed by string by variable name. What's going to be in it? Who cares? I don't care. I actually self-documented in my code there. Let's take a look at what the heck this is. Now, mark is used. Take that variable name and add it to the list, but I'm adding it to the list as the index value, not as the element that I'm putting into the index. In fact, it doesn't matter what I put into my collection. It's sort of like an indexed-oriented table. There's nothing but the index. That's all I'm interested in. Is a string in use? Go to that location in my array and use the exists method to find out whether or not that string is in use, exists as an index value. So all this code and all the testing and all the boundary condition analysis and all that just disappears, gone in a puff of smoke, and it's replaced by this. So that's the simplest example I can, or demonstration I can give you of how, by changing simply the way you index your arrays, you can compact your code. You can get rid of a lot of unnecessary code and write much more, I think, intuitive code as a result. So that's string indexing. Cruising right along, nested collections, another really incredibly powerful and handy feature in which you declare collections within collections, within collections, within collections, if you want to. This is something I'll just touch on briefly. The syntax can get kind of hairy if you're new to it, and there are a number of scripts on LiveSQL and others that will show you how to do this. But one of the things I found with it that is really cool is that with nested collections, you're essentially doing a kind of data modeling exercise in your PL SQL code. As I'm sure you know, if you don't get your data model right in your tables, you can end up writing truly awful, horrible code to compensate for the mistakes in design. I know that. I live with that on a daily basis. The same thing can happen inside your programs with your collection structures. If you declare a whole bunch of collections and they're not modeled correctly, you can end up writing a lot of code trying to sort out the details in those collections. If you do it right, and that can often mean nesting, the code simplifies, even though your data structure could be a bit more complex. Let's go to LiveSQL. See if I've got something here for you before I go to my code. Nested collection. All right, looks like we got some hits. So here's my string package, my string tracker package version 3, in which I maintain lists of lists, and I can have variables that are used in different lists. So it's a pretty generalized utility. You might find it handy, and you're welcome to use it. So now I have this idea of creating a list. I see if a string is in use within a given list. I mark a string as being used within a given list. Let's take a quick look at the structures. Here's my list of strings I've used, indexed by varchar2. I'm going to create a record that contains that list of values I've used. We're not going to get into the case sensitivity stuff, but here's my collection of records, and that record has within it a collection, so a fairly complex structure. Okay, let's take a look at marking a string as being used. So I mark this string as being used in this list. So I go to my list of lists, I go to that list. This is an array of records, so this is a single record. It has a field called list of values. So record.list of values. And the list of values itself is an array, so I go to the string, that location in my string indexed array of that collection, which is a field in this record, and I assign it a value that I don't care about. Is my string in use? I go to this location. We're not doing case sensitivity, so we don't care. I go to this location in this field of this record, and I ask, does it exist? And if not, then it returns false if there's nothing there. So I don't have to loop through my outer loop of my lists, my inner loop of my values within that list. I check to see when it changes. The logic is just as simplistic as can be, though the syntax in reading this sort of thing can be tricky. So again, sorry, it's kind of a blitz to show you that, but hopefully it just grabs your attention and gives you thinking about things you've done in your code where that might help. So collections within collections, cool stuff. Finally, my current favorite thing, table functions. So table functions are functions you can select from as if they were tables. And you can do all sorts of amazing things here. Essentially, there's a table clause, or really the SQL engine, takes the collection returned by a function and converts that collection format into a data set of rows and columns, or pseudo rows and columns. And you can then join that collection set with data in other tables and other table function values being returned. You can do joins and unions and multi-set operations, whatever you'd normally do. Now, why would you want to do this? Well, first of all, if you're following the smart DB architecture, in other words, you're really building a hard shell of PL SQL code around your data structures, and you're following the least privilege principle, you might not even want to grant select to tables and views to your developers. Well, what do you do if you can't select from a table? You select from a table function. So people actually build table functions around select statements to hide the selects, hide the SQL, and then expose it as rows and columns through that table function. In addition, it is, and more generally, it simply allows you to programmatically construct your data sets. So you might have to have this very complex set of rules that you want to build in real time to build a data set and then return it. Maybe it's possible with SQL. In some cases, it's simply not a SQL operation. It's literally programmatic logic. So the table function hides all of that logic and simply returns rows and columns. And finally, if you're like me, and you're not like Chris Saxon, and you're not like Connor McDonald and Stu Ashton and Tom Kite and so on, the folks who can spin up SQL statements that just blow your mind and can do just about anything you could imagine or not imagine. If you're more like me, in which your SQL skills are probably not quite current and not at your fingertips, you might hit a limit in what you can do with SQL. Now, what I do is then say, hey, Chris, can you help me out? And he usually can give me some SQL that helps. But in general, if you hit the limit on what you can do in SQL, but you can see a way to write it in PL SQL, then you might fall back on a table function as a way to get the job done. And programming is first and foremost about getting the job done. And Judith just said, I hope that Kim Berg-Hansen will not read that last point. Oh, because I didn't include Kim Berg-Hansen. Yes, if you're a SQL expert like Kim Berg-Hansen, who is our SQL quizmaster at the Oracle Dev Gym and also an amazing SQL guru. That's right, I'd like to be like him too. So table functions, before I move on. Let's go back to Live SQL. Actually, I'll go to Live SQL and to the Dev Gym. So in Live SQL, there's a ton of resources for table functions. There are a lot of different scripts you can take a look at, and there are also tutorials. In fact, let's go right to the tutorials, because this is something you probably are not aware of in Live SQL. Live SQL has a lot of scripts in it, but we also are building out essentially mini online books on using different pieces of SQL and PL SQL functionality. Chris Saxon has built a lot for his database for developers classes, and I've recently started a new class on the Dev Gym on table functions. Get started with PL SQL table functions. And this is a 4-module class that will take you through the basics of table functions, and then you take quizzes to reinforce your knowledge. And this is an example of one of the tutorials that comes with that class. So it takes you through what a table function is, why you'd want to use it, so on. And the cool thing about Live SQL, if you haven't seen this before with tutorials, is that we include the code. You just click on a button, and then you can run that code. So step by step, as we're teaching you about this functionality, you can try it out. Use the table function. Oh, let's take a look at doing that. Use that table function. Run my code. And there's the output from my table functions. So Live SQL is a great way to learn about this functionality. Check it out in Live SQL, the tutorials, or a variety of table function scripts. But I kind of hurried through that. My point was to show you the table function. So let's do that again. Sorry about that. So here's the cool thing. I've created this function called random strings, just returns n number of random strings. And it's a PL SQL function. I could use it just in PL SQL, but I can also put it inside the table clause. And as of 12.2, you can often leave off the table clause as well. And I can select from it as if it were a table. So that's the basic idea. Incredibly powerful, gives you an enormous amount of flexibility. Check it out. Okay, to sum up, so if you are writing PL SQL code these days and you're not using collections on an almost daily basis, something is wrong, something is missing from your code, something is missing from your life. You're writing code that's probably too complex and slower than it needs to be because you're not taking advantage of some of the latest features of PL SQL and this very important data structure. Do remember, you got to watch out for that PGA memory. It can really come and bite you if you're not careful about it. But my encouragement basically is get started with collections, get your head around them and use them as often as is appropriate. To make that easier, I have set up that PL SQL Collection Resource Center. So go to bit.ly.plsql/plsql-calls. It'll take you to my blog post. You'll see a number of links to videos, playlists, articles by Tim Hall and Adrian Billington and myself. And if you have ideas for adding more resources to that, just let me know and I will do so. Okay, that's the end of my presentation that of course went longer than I'd expected, and my apologies. Let's move on to some questions. So again, you can ask questions right now. We have a number of questions that have come in beforehand, and you can submit questions right on the AskTOM website. So in case you didn't know this, the questions I'm about to show you came right on this page through the Ask the Expert section. And if you sign in or provide your email, then we'll be able to get back in touch with you if we have follow-up questions. But right now, if you have a question you want to put into the chat and anything I just wrote about or talked about, or any other questions you've got, please go ahead and share your collection stories. Let's go. Okay, so this came in a couple of weeks ago, and it was actually perfect in terms of this particular session. So my billing information table contains 10,000 records. It takes 30 minutes to process the whole procedure. Can you help me locate the problem in my procedure? Now, this is like the heart and soul of the code. But what I'll also do is bring up the more complete example.
So just while you're doing that, we've got
Chris.
Question from Niels coming in. Says, are there more enhancements in 18C regarding the records collections besides constructors?
So the question is, do you want to answer it?
Yeah, so for those of you who don't know, in 18C, now if you declare your own PL SQL array or record type, you have an implicit constructor for it. And we've called these qualified expressions. Implicit constructors is more meaningful to most of you, I'm sure. And what that means is instead of, in the past, if you wanted to assign 3 elements to an array, you'd have to have 3 separate statements. So if you've got your my array type, you'd have 3 separate statements to set up each one. Now you can have my array type and then pass in all the elements in one go. So you get it's all one single statement that gets all that information in. So that's something that's new that in 18C, and hopefully Stephen's going to find an example for this.
I'm not sure I was having trouble finding it, but here we go.
Yeah.
Right, so go ahead.
So that's the key advantage, but there aren't any other particular changes in 18C for this, at least not that I'm aware of.
Right. So just to see the examples, and again in Live SQL, search for qualified expressions. That's the name for constructor functions for associative arrays and for records. You can read about why they decided not to call them constructors, but I'm not going to get into that. The basic idea is that now, right inside the declaration section, or in general, for every array type you declare, there's a function or qualified expression of the same name. And then you can literally build your collection in line. So before you had to do individual assignments, and now it can be all put in there. You have to use named positioning. You can also use it with string index collections, which I show right here. Here's an example of having a record constructor. So I'm passing in the field values, and then returning a record, and those are assigned into the elements of my collection of records. And Nils, that's pretty much it, unfortunately. There are some fixes, for example, to the block code coverage feature, which was first introduced in 12.2, I believe, or 12.1. So we can now automatically analyze code coverage, or which lines of code have been used. They enhance that a bit to make it more functional, and we're looking forward to seeing that exposed in various IDs to make it useful for everybody. And why don't we just keep seeing what people are putting in here.
Yeah.
Can you share the bit.ly URL again?
Yeah,
Well, I sure can do that.
I've just pasted it in, Stephen. So,
great. Okay.
So someone had a question, W. Cole, above that. Can you have a table function return rows that are the result of REST calls? So
I don't even see that one.
it's just above the request for the bit.ly URL. So I guess you're trying to access an external API, make HTTP call, and pass the results back as a table function. And yep, HTTP. Well, yes, you can. I mean, the short answer is yes, you can do this. As always, when doing these kind of things, particularly if you're going to be making a call outside your database, you've got to think carefully about how you're going to manage it. So in order to allow your database to access external locations, you've got to set up things called ACLs, access control lists, which tells it what it can actually get to. So you need to look at your permissions there to see what it can access. And you also got to think about performance there, because you're going to be making some kind of network call. So these potentially can be quite slow. So you've got to think carefully about, your performance and security requirements. So the short answer is yes, you can. There are some various examples around. We might be able to dig one out. But think carefully about security and performance and what it actually means when you're calling this.
All right, thanks, Chris.
Yeah.
I'll pass this one on to you since I've got you highlighted on the video now.
Yeah,
we use pipeline table functions a lot with the for cursor in select statement loop style. Should we be using bulk collect like the live SQL tutorial instead? In other words, I assume for record in select from table function versus a select bulk collect.
Yeah. So assuming that we were trying to convert that, then sorry, there's just lots of stuff flying, lots of questions coming in. It's a popular topic, this is, Stephen. Good choice. So I think the short answer there is to ask yourself, does it meet your current requirements? I mean, so if you've got code and it's working today and it's fast enough, then it's probably, I wouldn't go through and just rewrite it all just because you could make it a little bit faster. However, if it is running slower, or you need to access that code anyway because you're making some other enhancement request or doing a bug fix or whatever, then it is worth reviewing it and looking at whether you could change it and how much it will benefit. I mean, again, it's one of those things, if the cursor for loop only processes, I don't know, 5 or 6 rows, you're probably going to get very little benefit from changing it. Certainly probably not the benefit from the time it's going to take you. Whereas if it's processing 4,000 or 5,000 rows, yeah, you could well see a good performance benefit there. So my first answer would be is, do you need to change, or why are you changing it? But if you are going to look at that code anyway, it is worth reviewing and see if you can make it better. I don't know if you've got anything else you want to say, Stephen? Or
yeah, I think the thing to remember in general with the cursor for loop, whether you're selecting from a table function or not, the PL SQL optimizer automatically optimizes it to fetch 100 rows at a time. And I remember Tom Kite a long time ago used to recommend that you just go with that. And in fact, if you did bulk collect, just fetch 100 rows at a time. And don't worry, he found, and I saw something similar, that if you fetched 500 at a time or 1,000 at a time, essentially overriding the default of a cursor for loop, which you cannot change, you didn't really see much of a difference in performance. So the point that Chris made is the good one. Is there a problem you're trying to fix, or are you just looking for potential optimizations? Hypothetical optimization is usually not a good path to take. But if you get into millions of rows, fetching 100 at a time probably isn't going to do it. In which case, moving to fetch bulk collect with a limit probably would make more sense. And I'll switch to me as I'm now talking. There.
Okay.
Right. I'm not sure in terms of that question, in terms of should I not use a table function and just do a bulk collect in my code, that's a little bit of a trickier question to answer, because we'd have to really look at or better understand what's going on inside the table function to see what's going on in the table function, whether you need it at all. So I think we should probably move on from there. We have a question. I'm going to give this one to Chris because it's my favorite kind of question I don't like to answer. And as he probably knows, there are a lot of those. But this is probably different from what you're expecting, Chris. Why can't we provide elements in the qualified instructors in 18C for associative arrays, why do we have to use named positions?
Why can't
I'll
we?
give you a hint, folks. The reason I hate these kinds of questions is that why questions are generally really hard to answer. So what Judith is talking about here is what you see on the screen. You can't simply list individual values, even in an integer indexed array, and have it put it into 1, 2, 3. Chris, why not?
Why? Well, because we did implement that feature. It's a short answer. I think, you know, one of the things to think about there is what do you mean by doing this? And certainly when it comes to the initial element for arrays, there's tends to be a lot of debate over where they start. Some programming languages start with 0 and some start with 1. With PL SQL, we typically start with 1. So it's not necessarily clear if you just do something like that what you mean. It does leave it open to some interpretation. Certainly, if I was looking at that, I wouldn't be clear to me. I'm not saying that's the definitive reason why this wasn't implemented, but certainly I'm sure it was some kind of consideration. I don't know if you've got.
No, I think you hit the nail on the head there. And it's even worse than you just mentioned in the sense that do arrays start at 0 or 1. So in PL SQL, with nested tables and varrays, they start at index value 1. But associative arrays were pretty much designed from the start to be inherently sparse. You can have any value from -2 to the 31st plus 1 to +2 to the 31st minus 1 is valid integer values. And there's no preferencing of positives over negatives or 0 over 1. There's no sense of a starting point for an associative array. So I think that's probably the core reason. As you said, then there'd have to be some decision made. What does that mean? It would have to be documented. It would have to be clear to everybody. Maybe something you could change with a pragma. Who wants to get into that sort of stuff, right?
Mm-hmm.
I've got a mention from Snanishkar. I also found DML error logging as an alternative to bulk collect update. We probably won't want to get into that in any great detail here. Error logging or DML log errors with the DBMS error log routine is a really great ability to suppress errors at the row level within a statement, whereas for all statements allow you to suppress errors at the statement level. We'll probably want to come back to that really in context of talking about bulk processing. But the key thing, if you're looking at using log errors, and of course, you can just go to Live SQL and search for log errors. What is going on? Oh, tutorials. That's what it was. Yeah. I'm thinking, come on, give me a break. So you can see, here's a script I put together that shows the use of DBMS log errors and the log errors syntax. So do check it out, but we're not going to get into more detail on that today. We've got too much already lined up here on the topic. I have tables of 10 millions of records. Is it wiser to use a single update delete statement or use collection and for all? Chris, take it away.
So there's the performance answer and then there's kind of the maintenance answer. So in general, a straightforward insert or delete will almost always be faster than doing the bulk collect and for all. It's not guaranteed. There can be some weird edge cases where that doesn't hold true, but generally speaking, if you really care about performance, that's the way to go. However, when it comes to processes that run on millions and millions of rows, even running at their absolute peak, as fast as you can get them, they're still going to take quite a while, which leads to a couple of problems. One is, well, what happens if the process gets like 99% of the way there and it falls over? Do you really want to lose, 3, 4, whatever hours worth of work? Probably not. You probably want things to be able to keep going. Also, we've mentioned DML error logging. If there's like a single failure right at the end, one exception, it's just not good. So in those circumstances, having some kind of bulk collection for all processing just to help manage the maintenance of it and allow you to do things like log what's actually going on, keep track of the progress. Maybe you've only got a very short window each night of information that you can process. However, it's also worth bearing in mind when you've got something processing huge data sets like this is to look at parallelism. So there's parallelism in terms of like getting the database to do it all with the parallel hint, so it will spawn up things for you. But we also have this DBMS parallel execute package, which can split your work up into logical chunks. So let's say you've got 10 million rows in your table, you need to process them all, and you've kind of found that the kind of sweet spot for your processing is maybe 100,000 rows at a time. So you can use, as Stephen's got some code up at the moment, is divide the table up into chunks. So there's a few advantages. Each chunk is smaller, so if each one that fails, you're only affecting a small portion of your data. Plus, each one is going to run faster. So as long as you've got capacity on your database, you can spin up, have several of these running at the same time, reducing the total runtime for your procedure. So it's, and this is a good technique which you can use to, if you really got, let's say you've got a small batch window and you've got to make sure everything's done in that time frame, parallel execute can help, provided you've got those spare resources. Anything you want to?
All right, great. So I think a good quick sum up is you should definitely, as usual, you should definitely try to get it done in a single SQL statement if you can do it. And then if you run into issues with that, look at what you can do with tuning that statement, or fall back into PL SQL to break it up into individual chunks that, for example, you can save incrementally if that's appropriate. All right, let's see, moving on. We may never get to any of the questions that people logged in advance, though we should do at least one of those. Here's a piece of code that one of our attendees just pasted in. And I know there was already an answer posted in chat, but his concern is that he's new to PL SQL and SQL. He's got this cursor, he's going through the cursor and he wants to update the quantity, but he seems to be updating all the rows all the time. Chris.
Yes, well, it's updating all the rows all the time because there's no where clause.
There's no where clause. So remember, so I think just to talk about why, you and I look at this, and others probably on the call look at this and say, well, obviously you're missing a where clause. So part of what it should be is something like this, where, let's say ID, PID equals, and then it would be rec dot, you get the PID here. Something like this. There are also alternatives where you can do a select for update, and then you can say we're current of, but we'll just keep it simple for now. I think that's minus. Anyway, the point is that if you don't have a where clause, then the operation will apply to all rows. And I think the reason somebody might write code like this, which seems so obviously wrong to us, is that you're running this code inside the for loop and you're thinking, I've already got that row, I've selected that row out, so I'm just going to update that row. But all you're getting back is a record of the data in your select list. It doesn't know inside this loop, we don't know about the row you're on, again, unless you're doing something like for update. And then you can say we're current. I think it's we're current of. And then it will basically keep track of where you are and update that row. So that's the basic answer. The other thing is, I would suggest that you probably don't want to commit after each update. Maybe you need to do that, but more likely you want to do it at the end. Usually you don't want to have, whoops, sorry, what'd I do? You don't want to have individual row changes being committed without the whole thing, but you have to analyze what the transaction is for that. Okay, wow, yes, look at that long list of comments. Do you pick up anything else?
Okay. So questions from Sven. Is there a way to measure the PGA consumptions of a single complex collection? I'd like to add something to my instrumentation code to see the size of it. So Sven, you probably know about the technique I'm about to show you and know of others. And I think, in fact, there is a new one in 12C that I don't recall in terms of analyzing an easier way to get at PGA consumption. But I don't think there's a way to analyze an individual data structure. Sorry, I'm going to make myself visible here for the recording. So as far as I know, there's no way to look at an individual data structure and look at that consumption. But what you can do is use information from $session and session statistics to get amounts of PGA memory. So that's the name of the statistic for session PGA memory. So you can build, for example, a little show program. You have to have select on these views. And then basically, let's see, should have some example scripts here, memory analysis. Yeah,
these are all variations of the same thing, but basically, now I got it. Now I remember. It's been a long time. The My Session package. So basically, you can trap you get the before and after amount of memory. I'm not doing a great job of showing you something really easily here, but this is too much. Sorry, this should be simpler to show you. But instead, I'm just bouncing around through my scripts. All right, so it wasn't very successful there, but the bottom line is that you basically read the session statistic before and after, you do a minus, and you've got the delta around PGA. I believe there is now information in the data dictionary itself on the total PGA consumption used in your session, but you can actually do this on a step-by-step basis through your code. So if you want to look specifically at the impact of an individual collection being populated, just get your PGA memory before that step, get it after that step, write it out to a log, and then you can see what PGA consumption was used. Hopefully that helps. And DBMS session, get package memory utilization. Wow, that sounds really good.
Yeah, that's an interesting one.
Thanks,
it's not one I'm familiar with. It says it's describing static package memory usage. So I guess it's how much is being used currently by a particular package.
All right, so we will not go exploring on that now, but I think we'll take it as a little piece of homework to check it out. Let's see, back to my original script. So I know we've got some questions coming in, but somebody did spend a fair amount of time writing this code, so let's just take a quick look at it. So he sent us all this code saying, you know, it's running too slowly, 30 minutes, and I need to make it faster. And of course, the first thing you look at is you look for the loops, and you look for DML inside of the loops, and you ask, are they using bulk collect? Are they using for all? And the answer here was that, well, yes, they are using bulk collect, and even using the fetch with a limit clause, so that's good, not worrying about PGA consumption. But then you look further, and they're doing this, we'll come back to this multi-statement construction here. Then inside we have another loop with another fetch bulk collect, still good news, but then you get down to the bottom, or the core of it, boom, individual inserts. So if somebody ever comes to you saying, my program is, I have to work through all this data, make all these changes, and it's taking too long, and it's in PL SQL, the first thing you say is, can you do it in straight SQL? And I can't address that here at all. The second thing is make sure you're not doing any row-by-row DML operations. Row-by-row querying is bad, but it's not nearly as bad and expensive as individual inserts. So basically the idea is that this all looks good. You're fetching into these arrays. And then what you'd want to do is not insert into this table here, but add to for all to bind array. I'm just going to do a very simple refactoring here. So you pass in that bill info, you pass in the string, and you add it to the array. And then afterwards, so all you're doing is adding to the array. When you come out here, then you say, for all index in 1 through my bind array account. And then you insert here. So this would become my bind array index. And this would be my bind array index dot string, whatever that is. So always look for those individual line by line or row by row DML as the core culprit of your performance issues. Of course, there can be many other things besides that. The other thing that came to mind in this piece of code, it's not like it's a performance issue, are these multiple string concatenations. There's no reason to do this. So you don't have to initialize the variable to null. Well, I guess if you have to reset it somewhere. I suppose this is the resetting, but then they're doing these multiple assignments. You can just do this. Right, just build it up right there. Not discussing whether or not that code itself makes sense, but all these multiple string assignments really don't make any sense unless it's very complicated. You want to do individual tracing between the lines to see what might be going wrong. Chris, anything else catch your attention in this code?
Just that those strings look really weird. It's like,
yeah, well, we're not going to try to figure out what other people's
yeah,
logic
it looks
is all
like
about. The world out there is very weird.
Yeah, yeah.
No question about it. My code's never weird, but everybody else's code is. That's what I found. Okay, back to the PowerPoint. And let's take also a look at in our session. I think we're pretty well caught up. Okay.
I think so, yes.
Okay. Would you want to take this one?
Yeah, so this is kind of an interesting thing. It sounds like based on the value of some variable CDS, they're choosing which SQL statement they want to do. They're asking how to consolidate it to one statement. And so the first question I have is, right, well, do you really need to actually consolidate it into one statement? You know, I know we quite often say it's better to put things into SQL, but when you try and cram too much logic into a single SQL statement, particularly as we're doing as is the case here, we're actually selecting different tables based on some other parameter. You're better off just having the separate statement sometimes, because you're going to get the more logic you like, particularly conditional logic, you try and force into a single SQL query, that much harder it becomes for the optimizer to find out what the best plan is, or what the optimal way to run the query is. And ultimately, eventually just falls back and says, well, I'll just full scan every single table that's in the query here. So that's kind of the first question, is why is this person trying to consolidate these into a single query? Because we can see we've got quite different where clauses and 2 extra tables depending on that parameter. So I probably wouldn't bother. If you needed to, then you can actually use case expressions in the where clause and use that. But it's a bit it's tricky to kind of answer without stepping through what all these values actually mean and what they are, I think. So
for sure. And I really like the general answer, which is this person might have a mind like mine. I tend to be kind of obsessive about avoiding any redundancies and like making things as concise as possible. And sometimes, well, often that has a very large value in your code base, but sometimes you can overdo it. You end up with something that's really tricky, complicated to read and understand and maintain, but it's really cool because there's no repetition. It doesn't mean that that's better. It really doesn't. So avoid overcomplicating your code to achieve some sort of abstract goal that doesn't correlate with user requirements, for example, and user satisfaction. Here's another one that I couldn't make a whole lot of heads and tails of, but we'll put it up here just in case. If you're on the call, by the way, and we're wondering what you're actually asking about, you can feel free to chat about it. But this person submitted this question with, well, 2 records with 2 different timestamps, but the statement only returns 1 record. Chris, any thoughts?
This one baffles me again, to be honest, because it looks like those ID service, assuming that ID service is actually that first column in the 2 records at the top, then those numbers are different from the ones that are in the query, which might explain it. But otherwise, again, you're selecting down to the second for those timestamps, but you don't have the full precision. So,
it seems to me that that's the core issue, is that you're converting the string without the precision to a timestamp. So of course you're not distinguishing between those 2 records. They have different precision, different sub-second precision, and you're glossing over that. So it seems to me the main answer is that if you're going to use that where clause and use to timestamp, you have to include the precision of what you're looking for. Otherwise, you're of course going to find a match down to the nearest second, and that's it.
Yeah. So it's, I think this is one where we need to see exactly what's going, or as Sven's saying in the comments, or missing parentheses, maybe it's to do with, because we will take, though maybe those service IDs are supposed to be like an in list as opposed to be separate, the ID service 9925 and the timestamp check will be done, and then we'll OR it with the ones that have ID service 26. Maybe it's supposed to be the other way around. So this is one where we need to see the full data, or a complete example to really get to grips with it.
Good catch, Sven. Here's a comment from Frithold. I like table ... where order by, in-memory filter and sorting of collections. Is there a good way of mixing 2 collections to a new one? Want to take that?
So you can combine collections in SQL with it's multi-set operators, isn't it? So like in standard SQL, if you want to combine two tables, you can put a union between them, and then you'll get a list of all the rows or all the values from both those tables. We have the similar concept for PL SQL arrays with multi-set. So there's multi-set union, intersect, and
Minus.
call it minus, yeah.
Sorry, except. It's multi-set
except
for the minus.
That's what yeah. I thought it was different. Yes. So they do the same. They work on the same principle, but on arrays rather than SQL tables. So that's the kind of basic principle with those.
Yeah, I think that would. I mean, we may not be right on target with what you're asking about in terms of mixing two collections to a new one, but in PL SQL, so I'm showing you PL SQL code here that combines two different nested tables, and this only works for nested tables, not for varrays or associative arrays. So within PL SQL, I can merge them together with a union, with an except or minus, or even an intersect. You can do the same thing within SQL statements. So hopefully that answers your question. And back to the PowerPoint, we're almost out of time. Let's see what else we got. All right, I think this would be a good one for you, Chris. So the question is, I've got a lot of records I need to insert into this new table. Should I do an insert select, inner join, et cetera, or use PL SQL, create a temporary table, et cetera, et cetera?
Yeah, so this is an interesting one. We actually had a similar kind of question come in the SQL Office Hours last time. And again, to be absolutely certain, you really need to test and run this out for yourself. I mean, I think generally when it comes to performance, as Stephen was saying earlier, people are pretty bad at guessing where optimizations can be made and how big those are. But here, what you're doing is you're running a query and then either putting it straight where you want it to go, or you're running the query, putting it in a temporary data store, querying that data store, and then putting it somewhere the final place. Mm-hmm. So in method one, you're doing an extra write and select. And I really struggle to see how method one would ever be faster than method two, because you've got that whole extra write, insert, and then query again process, because you're doing all the work for that query, all the work to insert to the final table, plus some extra work reading and writing from your staging method two, where you've got the temporary table. So I really struggle to see a situation where method two would be faster than the straight insert.
So thank you so much for joining us. Hopefully you got a lot out of the session. You contributed a lot. Great questions and great expertise. Thank you, Judith and Sven and Nils and others. Hopefully you'll join us for our next month's session.